Hello. Most of the business type work I do is industrial electronics, and most of it's on customer sites where I can't film anything, or it would be difficult and I have to, get through all the complications and stuff, and be very, very careful what was shown. But for a change, I've got something on the bench. It's a Siemens servo drive. It's 130 amp 3-phase input, DC output, or single phase or rectified DC output, thyristor controlled. The machine it was on had a problem with the motor. It just had a carbon build up around the brush gear, and it ended up flashing over. The motor's been repaired. The customer's put that back in and then found it still doesn't run. It tries, and then the drive trips out with an overcurrent fault. So looking at it, at some point before they got the machine, apparently, the previous owners had swapped the proper semiconductor fuses that will protect thyristors and power devices for a big old circuit breaker, probably because they had problems before with the drive or motor and it kept blowing fuses, so I thought they were saving money. The trouble is, all they do then is it might stop the wiring catching fire, but the thyristors will be destroyed, and a lot of other damage will be done far faster than a normal circuit breaker will trip. Now, I've already stripped it down to start doing some tests on it before I thought of doing a video, but I'll just quickly show you what's what. As you can see, it's they're quite nice old drives to work on these. The thing's actually about 1986 vintage. All the drive cards individually fold out so you can access them. This is actually looking at it upside down for ease of access. This would be the top when it's mounted. But you can just hinge all the drive cards down individually. They're all discrete normal components. There's only a few special parts in it, such as the power transformer, which is a little 3-phase one with multiple outputs. But everything else, it's generic parts, if you like. Like I say, there's an on317, just general TTL and analog ICs, op amps. So they are very, very repairable as long as you've got the schematics. And with the older machines, you used to actually get a full set of schematics. Now that one's the field control board, because it's a constant horsepower spindle motor that's been run on this one. So once it gets to full armature voltage, it starts reducing the field voltage to increase the speed and maintain full horsepower. So that's just running off of 2 of the 3-phase inputs, and it's a single direction, it's 2 double thyristors. I don't think it reverses the field. No, it's only firing 2 thyristors. Oh, sorry, I think that'll be thyristor diode combinations. They've got the flywheel diodes built in rather than dual thyristors. And then that's the actual power module, if you like, or power section. Now, as assembled, it has these snubber modules slid between the thyristors. The resistor capacitor snubber across each. There's 2 of those. The copper bus bars linking the top and bottom, and then bridges in the middle for the output or the AC inputs. Sorry, that way on. So the 3 centre terminals are the junction between 2 thyristors in each module, and then the other 2 terminals in each module are the opposite ends. So basically each module is wired to have 2 thyristors in reverse parallel in these 2 connections. Can't actually see the symbols on the things at the minute. I'll add a drawing of that. Anyway, that's the layout. Oh, there's also then a firing card on top of that. That's on top of the busbars, which has pulse transformers and limiting resistors for each gate drive. So 6 double thyristors and 12 transformers, 6 pairs. it links up to the main boards by a couple of ribbon cables where it's mounted. But anyway, onto the diagnostics. Let me just get the camera mounted up. Adjust the view a bit so I won't be able to see both the thyristors and the meters. So I think somewhere around there. Right. Okay, as I said, I've already done some quick tests on this. First of all, I went round it with the Thyristor tester. I'll just get that out. This is a gadget of my own design. Basically, it's a controllable current source and a couple of load resistors that allow thyristors to be tested for sensitivity and leakage at low voltage only. So if I connect this, if I remember the right connections, connect. Come on. These will fit on here if you just get them right. No, that one is apparently dead. It was working, but as I said, I've looked at it since and it did give some weird readings. So it might have actually just been partly recovered and died again. Try a different thyristor. Ah, that's better, that's what it should do. Right, so that one is now working. I can wind the current down to see what it fires at. So it fires at about 80 MA, not at 70. Yeah, 80, 90 MA. They're normally 150 guaranteed to fire on these, typically. Oh, that's supposed to be battery test. If I hold the reset button in, it shows the battery voltage. That's where you get a temporary reading on there. So at about 100 MA or so, they should fire, which that one is doing. And as I say, when I went around them earlier, they were all firing. They were behaving perfectly, but this is only working at about 8 volts. Yeah, I've got the connection sorted out. That one is working at that end. Swap the connections to the other thyristor in the pair. Yeah, okay, yeah, so it just either not got the leads right or something. So anyway, yeah, so that's the idea with the Thyristor tester, and they'll fire perfectly. I mean, sometimes they'll fail open and they just won't fire when you test them. So that's an instant, fact that they are dead and need replacing. But these all work at low voltage and they've got a reasonable firing current, the 100 MA or so, 1900 MA for 150 MA rated devices. So they seem fine at that. So the second stage is to mega them. They're rated at 1600 volts breakdown. So they should stand 1000 volts with no problem at all. I've got the meter set on 1000 volts here. Probes are dodgy on this, I've lost one. Where's that gone? Need a new lead for that, obviously. But this is 30 odd years old and it uses non-sleeved plugs. So anyway, right, so if I start, they should be open circuit at 1000 volts on all 6 combinations across the 3 terminals. See, that's over range, no leakage. Likewise, if we reverse the probes and do the same combinations, that's the all 6 possible ways. That's a bit of leakage on that. I mean, in itself it doesn't mean anything, 100 odd megs, but what in reality I'd not trust it, because there shouldn't be any, and what it can mean is they'll start to break down under load when they're sustained, you know, 600 volts or more across them, and could be falsely firing or just short circuiting. Now this is the one I believe that when I was testing before seemed a bit dubious. Yeah, see that it's jumping about. It went to about 1 point something megs. That is not at all good. That is definitely dead. Yeah. It's not just the leakage through the power circuit, it's leakage to the gate. And what it means is the thyristor can fire when it shouldn't. Even though you think the leakage is trivial, there's enough to possibly cause false firing. And that's what the drive was locking out on when the motor was put back in. It was coming up with an overcurrent fault, even though the drive was running very slow. The motor was running very slowly off load. I think when it flashed over, the extreme current with no proper fuses to protect it just blew up a couple of these. They just overloaded them. Another thing I noticed on this that I don't like is at some time it's been repaired and someone's found one faulty thyristor and replaced it rather than placing the set. And that's something I never do, if at all possible. I mean, if you've only got one device and the machine's got to go back into service, it doesn't matter, but if you can get all the devices, if one's blown through due to an overload, that overload's gone through all the components, so you always replace the set. Anyway, I'm not going to go through test them all again because I know for a fact they need doing. You can see that's that one's a semi-chrome one by the look of it, whereas these are Siemens originals. So that one's been replaced in the past. You can see it's different terminals and everything. It's got extra terminals for the cathodes as well as the gates, whereas the Siemens one's only got 2 small terminals for the gates. So that's it. There's a new set of thyristors. I also need to test all the snubbers, because if any of the snubbers are faulty, that could be causing problems with false firing and overloads, and again cause damage. So let me just test all these. None of them look scorched. I mean, sometimes you see that with these old drives, you see the resistors actually looking cooked, quite discoloured. Nope. That capacitor's reading dead. It's supposed to be a 0.1 microfarad. Nope. Nope. That's strange. These are cross-connected in the module. As you can see, when I was moving capacitor to capacitor, it was giving some other readings, but I wouldn't expect yeah, it's a kind of delta arrangement, but it's got capacitors in series everywhere. There's no direct resistance across any two connections on the capacitors. That's an external terminal. Goes to a resistor, other end of the resistor, capacitor, other end of the capacitor, another external terminal. And that's it. There's 3 external terminals, well, actually 4. But there shouldn't be any direct connections on those, so it could mean all these capacitors have died. But there again, let's say they're 1986 or around there, so it is possible. Yes, let me see the print on that. Okay, that's me trying to use this for something that I didn't realise it wasn't intended for. It is a capacitance meter, but it's just a low value capacitance meter. It's made for electrolytics, that type of thing, rather than small caps. And this is a brand new ceramic 0.1, which according to that, it's too low to test. That's all it is, it's just not suitable. I thought it was just a convenient thing to use in the video, but it's not. If you use the fluke, get that so it's readable. I get that on capacitance. Then all of these test fine. If anything, a little bit over. And likewise the resistors. I've checked these 3 already, but very close to 82 ohms, easily within tolerance. So there's not a problem with the snubbers as far as I see. It's just purely an overload from the motor flashover. Right, okay. So I'll carry on with the thyristors when I get them. Okay, parts have arrived, so it's now time to swap the thyristors. These are some of the replacements. So they're a dual thyristor module, anode and cathode common on that end, one cathode there, the other anode here, and then the gates are brought out on the outer 2 of the small terminals, and cathodes for convenience. I'll just try to have them wide like that, only uses the gate terminals, and cathodes are taken off the power terminals. It's basically you just unscrew these. Washers. Add a bit of thermal grease and put the newers back in and swap the firing leads over. Oh, that stuff is very, very nasty. Needs cleaning up and a bit of fresh on, definitely. I think we've ever changed that, but they're replacing the stuff. I think I'll just remove the whole lot and clean it all over as an area. Also add some, in fact I might use there's bolts come with these, set screws should I say, cathode set screws, with appropriate washers, and they appear to be the same. I'm not sure if these are 5s or 6s. Oh, they are 5s, aren't they? Oh, these are tap tights. Notice the triangular section. 3 thread forming screws that leave a perfect metric thread. But you don't have to pre-tap the hole, you just drill it the correct size, about half the difference between the core and outer diameters. Yeah, that's an original one. The grease is actually better condition on that than it was on that replacement. Stand these on a bit of paper so I don't mess my bench. So the hinged back cars are just rattling against something on the back of the bench. Back screws are going to be slightly awkward. The screw nose is a bit too long to get under the cards. Just get to arrange these so I'll put the wires back in the same location. Some of them have got extra bits of wire tied on like that. Not all of them. Oh, I don't know. Actually, looking at those backs, they have. I didn't notice one of them. Yeah, the back three have all got the extra bit of red wire on that goes to the snubber boards. Grey one as well. I thought the other one had a grey one as well. No. Not paying attention. So I'll be swapping the firing wires 1 for 1 after the new thyristors are in place. Quite dried and gooey, but there again it is somewhere between 30-40 years old. And you've got solid weight to clean it finally. there's as much black crud as old compound coming off the top. That's there. A bit of corrosion actually. Can't feel anything, but there's a mark. I think it's the same as these. It's a bit of condensation sometimes. Probably is. This stuff gets everywhere. Doing something. That'll do. Okay, got one of these little accessory packs up. See if the screws are the right thread, which they look to be. Something like long enough as well, because there's a very thick heatsink. And oh yeah. Near enough. They'll go well in, far more than needed. Yeah, there's a good thread in the heatsink. They'll do fine. So I'll use those instead of the positive ones. Just rather have the washer and the spring washer, a bit more vibration proofing. These are the ones Semicon supply for the devices, so they should be right. Don't need the little link plates and things with these, so all the internal screws. And the internal screws will just end up going in the bin probably. So never found a use for those in anything we do. Right, okay. I believe it's going to be that one. And thermal grease. Got two different types here, which is more appropriate. Both going to be way better than the basic zinc oxide stuff that was in it. I'll use the bigger one. A tube of this a while ago, or some same size tube, I don't know, different make. I think it was a, can't remember what make it was in fact. The stuff was so thick, you used to have to use both hands and lean on the back of the tube to push it through. I don't know what was up with it, but it certainly didn't flow. But, just a fine trace on each one. That's more than enough because it will spread out. You don't want to layer, you just want it to fill the imperfections in the metal and give better contact. Thick layers actually reduce contact rather than improving it, as well as just being plain messy. Yeah, it's a decent consistency this one, it comes out of the tube easily. tapered ones first at the back. This will fit. Will it? Yes, just. Try and set the things, the sensor on the pads, all the clearances, to make sure that the power connections are going properly. Right, one pair of snubber trays. Now, okay, I'm going to have to pause again because I can't remember which way these goes, and the photos are on this device I'm using for recording. Okay, there's resistors towards the centre. Right. These, the centre thyristors and the snubber inner's. That's the next test of alignment, see if these will take the power screws. Actually, these use these little screw assemblies as come with the thyristor bulk of it, so I could also take those. The only difference is the old ones are Phillips, the new ones are Posi-drive. I'm using a Posi-drive driver, so I'll give it a new set of screws. No, I need more things. I need to pause. I need to print the photos really, so I can cross-check what I'm doing at the same time. Right, I've the reference photos printed out. So there's disassembling it. Looking at those, I do notice something I couldn't see on the image on the phone. It says A2 or whatever it is there, or A5.2. So I've actually swapped these round. Nothing's bolted yet, so just pull them out and put them back the other way around. Right. check. Now there's none of the smaller wires auxiliaries, and these power wires. There is under one of those, but not on the same screw as other power connections. Oh, there's one at the front here. That's those two. They're gone. Presumably armature voltage feedback to the field controller. Seems to make sense. Because it's a constant horsepower mode spindle drive, the field control part needs to monitor the armature voltage, and as the speed command increases, set point to drive. After it gets to maximum armature voltage for the whatever it's set to for the motor, to keep increasing the speed, it has to reduce the field voltage instead. So the field controller needs the DC output voltage, which is on those two buses, as one of its inputs to control the field and modulate the field current. Right, that's all those in loosely, all the power wires in place. I might as well put those two in just for the hell of it. They're wrapped around there. They're supposed to be a knot, but I'll unwrap them. Again, loose. It just gets everything in to ensure they are in usable alignment once you put the small screws in. Right, now, and also need the firing wires, which are still on thyristors. Now these semi-chrome packs come in two versions with different terminal arrangements, just to confuse things, for some historical reasons, I believe. These have the gates on both outer terminals of the four. There's a B version that has them alternate gate cathode, gate cathode. If you ever use these things for anything, you need to be aware of which type you get, because lots of suppliers keep both and the price is about the same, but the availability may vary from one to the other. So as long as it's something that's wired rather than straight into a circuit board, you can use either. You just need to be sure to pick the correct terminals when you're putting the firing connections on. Right, so there's the last three auxiliary firing wires to go on. which mount to these other two holes in the snubber connections. Right, I'll make sure these red wires are in the correct groups when I put the board on top. So that one should be there. And the grey ones, in fact. It would not work very well if I crossed firing connections between thyristors. I mean, they're all cable tied into pairs on that end, so they can't get confused, but these are all separate loose wires. Right, put that power terminal screw back in. And the next bit is the pulse transformer board, which is there. That goes that way around, and it will connect to these two ribbon cables once it's in place. Just give that a screw another check, see if it's settled at all. Okay. Just a quick idiot check for loose bits on the bench, but I can't see anything. There's nothing trapped, putting excess pressure on anything. That's better. And one of the terminals was a little bit sprawl. Forcing the wire upwards a bit more than I like, so I just press that down. It's only copper, of course, it's bent easily. Right, all the wires go on in the same sequence, working clockwise around it. That's the yellow, slate, red, yellow, with the two yellows being the outer two on each thyristor. Right, multimeter to hand. The jump moves, so you can see that. Now, I'm going to test between each of the three-phase inputs and the power terminals on the back, and also between each of those and each of the DC ones. It should hopefully all be open circuit. Yeah, some bit of leakage from the snubbers or whatever. And charging the capacitors in those. There's no short circuit, so that's the thing. If you've got any very low resistances, then it could mean I've got gate wire swapped between different devices, gate or cathode wire swapped. But, that seems okay. I'm not seeing shadow back there, but it's actually got sleeves. These are bare. Those have got sleeves on, so I'm not actually getting the contact. I wonder if it's not showing any readers at all. There you go. And of course there are other things connected, and it depends on the polarity, so I expect some slight readings, slight oddities. That's just the meters getting confused. Right. All the connections are fully seated. Yeah, the actual gate circuits normally read something like somewhere between 15 and 30 ohms. Yeah, that's reading 15 ohms. I believe they've got loading resistors internal to the thyristors, because the thyristors themselves, that's not the firing circuit, that's the thyristor itself. I don't know if that's even, yeah, it's got a diode in series, so on that range it's not showing anything across the transformer. Right, now back to the more important stuff. 2 fire needs need to go back in there. That, I believe, is it for the actual repair. As I say, very nice to have to work on these, though they're sometimes rather awkward to fault find, because of the complexity of the analog boards. Like I said, this is obviously upside down, but when it's mounted, you just pull the boards out. There's a rack that holds them in, a frame there. You can hinge all the boards out one at a time to examine them. And they've also got individual connections, which can be a pain to get a screwdriver in sometimes when you're trying to work past other boards. But they're not bad. And so that's the pain. If that goes, the supply transformer, if it's multi-wound special transformer, then it's time to start looking on eBay or use a different drive at last resort. boards are falling out of place because it's on its back rather than stood up. That's it. Can't actually see that. It's a hinge frame that grips the tops of the boards and keeps everything solid. But that's it. Ready to go back in the machine.